Hi, I'm Rob. In this video, I'm going to show you how to install an RT range system for vehicle-to-vehicle communication. We're also going to be using an RTX LAN, which you can see fitted on both vehicles. I'm going to be showing you how to install a dual antenna RT system into this car. We'll be securing the RT in the vehicle with the RT strut quick mount system, and we're going to place it in the center of the vehicle. When you're setting it up, raise the silver lever, move the strut until it touches the roof, lock the black lever in place, and then close the silver lever. We also offer extension legs for the RT strut and an extra long version to suit really tall vehicles. Next, we're going to attach the brackets to the RT. We recommend that the RT strut is mounted in an area separate from the vehicle occupants, such as the boot or trunk of the vehicle. This is the safest option. However, if you need to mount the strut in the centre of the vehicle, as we're showing here today, an additional restraint should be used to hold the strut firmly in place. Fitting the strut in the centre of the vehicle means the IMU is closer to the vehicle's centre of gravity, which is an important factor when collecting vehicle dynamics measurements. With the screws in place, we now attach the RT to the strut. It's as simple as that. The next job is to fit the antennas to the roof of the car. In this case, we're going to mount them in the centre of the vehicle, just for ease of use, but there are a couple of things we need to watch out for when we're doing this. The antennas need to be placed at least 30 centimetres from any edge, ideally on a metal surface. We also need to make sure that the cable exits the antenna in the same direction. This is quite important. The antennas we're going to designate as the primary antenna, which is at the front of the vehicle, and the secondary antenna, which will be at the rear. We'll use that later on in the configuration. As part of the configuration, one important measurement we need is the distance between the primary antenna and the secondary antenna. Ideally, these antennas need to be placed between 1 and 5 metres apart. This measurement is quite critical. We need to be accurate within 5 millimetres, ideally 3 millimetres. In this case, the distance between the antennas is 1.03 metres. I'll make a note of that and we'll enter it in the configuration. Now we've positioned the antennas on the roof, we attach the primary antenna, which is the one at the front of the vehicle, to the primary antenna port, and then the secondary antenna to the secondary antenna port. So now I'm going to attach the main user cable, which is keyed, so it only fits in one position. We'll lock that in place, and now we're going to attach some of the other connections in a second. Now all we have to do is place the radio modem antenna on the roof. The next task is to connect the power supply. In this case, we're not using the standard power cable supplied with the RT, we're using an RT UPS, which is an uninterruptible power supply. By using this, we guarantee that there are no problems during the starting of the vehicle or if somebody accidentally turns it off, because we'll get 3 minutes of power from this device. I'll just connect the power now. Because we're using a base station in this test to achieve 1 centimetre accuracy, we need to use a radio modem to receive the differential corrections from the base station, so we'll attach that to the user cable now. We've now got the unit securely mounted to the RT strut. We've attached the primary and secondary antennas, the power supply is connected and the radio modem is as well. We're now in a position to take some measurements ready to use in the configuration. For the primary antenna configuration page, we need to take 3 measurements. We need to tell the system where the primary antenna is in relation to the IMU measurement origin. In this case, we're going to measure how far in front of the IMU the primary antenna is, how far above it is, and then we'll look from the front to see whether it's to the left or the right. We need to be quite accurate with these measurements. We need to measure within about 10 centimetres. Next, we'll mount the base for the RTX LAN. It's important that the surface you're going to stick this to is fairly clean and fairly flat. Press the base firmly on the window, keep the entry for the pole upright so that your antenna points in the right direction, and then press the blue button until you can no longer see the red line. Finally, make sure it's firmly fixed. So now we've attached the RTX LAN to the antenna, and we'll just attach it into the suction cup mount, and we're good to go. The next thing we need to do is to install the RT Range S Hunter. I've already attached the brackets that we're going to use to mount it to the RT strut, so we'll do that now. The RT Range S has two power outputs. Power will come into the RT Range S here, and the power supply for the RT will come out here. We're going to use one of these to power the RT. The next cable we'll attach is the cable up to the RT LAN. The connection for this is marked on the front panel. Measurements from the RT are sent to the RT Range S via Ethernet. We've also attached the other end of the cable to the RT user cable. The final connection to make is the power input for the RT Range S. Once this connection is firmly made, we can then attach power to the other end of the cable. We've now finished installing all the hardware in this vehicle. The RT is in position to measure position and is connected to the RT Range S via the Ethernet cable. We've also got an RT LAN ready to receive information. Before we configure this RT though, we're going to set up the equipment in the other car. So I've just finished installing the hardware in the second vehicle. This is going to be our target vehicle. The installation in this is virtually the same as we made in the first car. We've got an RT strut with an RT mounted on it, and we're also using an RT range. The difference is this is the target version. We've attached an RT LAN which is going to send information wirelessly back to our Hunter vehicle. As a final check, I've quickly powered the system up and attached an Ethernet cable from my laptop to one of the spare Ethernet ports on the RT range. This way I can check and make sure I can see this system and that everything's working. So the first thing we need to do is launch the RT Range software. To access the RT Range configuration software wizard, we're going to click on Real-Time Display, and at the top of the window we're going to click on Configure RT Range. The Nav Connect window opens to show us the live connections. We'll simply move this out of the way and move to the RT Range wizard. Use default settings is selected for us initially, so we'll simply click on Next to move to the next page. The first thing we need to do on the Hunter target setup page is select the IP address of the RT in the Hunter vehicle. We'll leave the data rate set at 100 Hz as this is the rate of the unit in the vehicle. In this scenario we're running one target, so we click on Number of Targets and select 1. As the target we're defining is a mobile target, all we need to define is the IP address of the RT inside the target vehicle. We can then click Next. For ADAS tests that require lane measurements, such as emergency lane keeping, we would configure the lane measurement parameters. In this case, we don't need those, so we'll simply click Next to move on to the next page. On the range measurement page, we're going to define several parameters. The first thing we need to do in the Hunter vehicle is define the position of the sensor. In this case, we know it's in the center line of the vehicle, but it's 2 meters forward of the RT. We can then move on to configure the target vehicle by clicking the Target 1 tab. In this case, we're going to define the target using a polygon. We'll check the Use Polygon checkbox, which opens the Target Polygon window. To save time entering this information, we're going to load a polygon. To do this, we click on the Load button and then find our vehicle polygon and click Open. We can now see the polygon has been loaded into the polygon configuration window and simply click OK. Now that the polygon is loaded, we'll move on to the next page by clicking Next. And that's it. In this case, we're not going to use any of the options that the RT Range offers, so we can simply move on to sending the configuration by clicking Next. On the commit page, we simply select the IP address of the RT Range in the Hunter vehicle and click Commit. We can then see the configuration is being uploaded to the unit. We then click Next. We have the option of saving the configuration to the PC's hard drive. However, if we choose not to select this option, it can also be downloaded later from the RT Range using the RT Range configuration wizard. Now we've finished our configuration, I can send it to the RT. I've connected the Ethernet cable and I can see the devices online, so we'll send that now. There are many more options, of course. This is just a very basic setup to get you going. And that's it, simple as that. Now we've finished creating our configuration, we've uploaded them into the systems. We're now in a position where we're ready to go and begin our initialization.